Hello, my name is Beth Dixon, and this is a video series based on Vicki Borlaug's PowerPoint presentation on hypothesis testing for the mean using p-values. I wish to thank Mrs. Borlaug for allowing me to use her PowerPoint to make this set of videos. If you are ever asked in the workplace to do or interpret hypothesis testing, you will most likely be asked to do so using the p-values. Most computer software, as well as our TI-83 and 84 calculators that we use at Walter State in our statistics courses, complete hypothesis testing, giving the results using p-values. So how do you use p-values to do the hypothesis testing? Basically, it's a comparison of the p-value to the alpha significance level, or the alpha risk value. So if the p is less than alpha, then we reject HO. If the p is greater than alpha, then we do not reject HO. The p-value is a probability of getting your sample data. So if the p is low, it is unusual, and the null must go is the phrase that we will use, and we reject HO because our data is unusual. If the p-value is greater than alpha, if the p is high, then it is an ordinary value and we do not reject HO. A way to help you to remember this is the two phrases that Mrs. Borlaug uses. If the p is low, the null must go. If the p is high, we let it fly. If the p is less than alpha, there is something unusual going on, and then we reject HO. If the p is low, the null must go. If the p is greater than alpha, then everything is ordinary. We do not reject HO. We let it. If the p is high, we let it fly, let everything stay, and we do not reject and make no conclusions. I will begin with an example with 7 weights. So we have the weights of 13.8, 9.7, 6.2, 15.3, 23.1, 16.7, 13.0. We will assume that they're normally distributed with a population standard deviation sigma unknown. Test the claim that the mean weight is less than 16. Use an alpha equal to 0.05 level of significance. The first step is to input the data into a TI-84 or TI-83 calculator. You will press Stat, then choose Edit under the Edit menu, and you will see List 1, and you will type in your numbers under List 1. If you need additional help with this, there are earlier videos in this series that will help you do so. Once you have done that, we will let the calculator do most of the rest of the work, but we do have work that we need to show on our paper. And the first of that is to find the null and the alternate hypothesis. So we will write HO and H1 on our paper, and we need to decide what our alternate hypothesis is. For Mrs. Borlaug, remember that we read the phrase, test the claim that the mean weight is less than 16. This is what we want to prove, and we will put that in H1. So to find the alternate hypothesis H1, look at the claim and place it in H1. And the claim will never have the phrase with an equal sign. If you're with another teacher, you may want to you will need to look at it a little differently in the fact that you want to look at your claim and see if it contains the condition of equality. If the statement contains an equality, it will go into H0 or your null. If it does not contain the condition of equality, which ours does not, it will go into H1. In either case, the claim that the mean weight is less than 16 should be H1, mean less than 16, and goes into the alternate hypothesis. Next, we need to find the null hypothesis, or H0. And the null is always the complete opposite of the alternate. The alternate and null are opposite statements. So what is the opposite of less than 16? That would be greater than or equal to 16. This gives us the null of the mu greater than or equal to 16. Next, we will use the calculator, and to set up the calculator to do the hypothesis testing on the mean. You will press Stat, then arrow over to Test, and then under Test you will choose the t-test. Under the t-test you will get a menu similar to the one that you see on the screen. We have data that we've inputted into list 1. So when it says input, select data. Make sure the word data is highlighted. For mu sub 0, that's our null. Our null is talking about the number 16. So we need to be sure that we've typed 16 here. Next is the list. Which list did we type our data in? So this should say list 1. The frequency would be if we had a frequency list or number. We do not have that, so it should stay a 1. Next is the decision here as to whether we're testing the claim to be not equal to, less than, or greater than. Our claim is that it's less than. So here we're testing the claim that the mean weight is less than, or our H1 is less than 16. So we should select, of the three, the less than symbol, and it should be highlighted. Next, we will select Calculate to do the hypothesis test. Once you've done that and got the results, you can also go back and return to the same menu and select Draw to see the graph. I will show both results on our next screen. Here are the results from your calculator, both the calculations and the graph. Notice the p-value in both and that they are the same, as well as some other information that we have. Next, we want to list what our alpha is and what our p is. Our alpha is the level of significance, which is 0.05. Our P is the area of the tail made by the data's t-value, and that is 0.1775, and we will round this to 4 decimal places. Since the claim is less than, the P is the area in the left tail, the probability of being in that left tail. Notice the H1 here is listed as the mean being less than 16, and that is the alternate hypothesis. And that's the area to the left of the t-value. Notice that it calculated the t-value for us and gives us negative 1.002. and the p-value is given as 0.1775 in the graph. So remember what our null and alternate hypothesis were, and next we can compare the p-value to the alpha value. The alpha value says we have an area of 0.05, and notice how Mrs. Borlaug has graphed that on the normal curve. And remember the phrases: if the p is low, the null must go. If the p is high, we let it fly. Since the p-value is greater than the alpha, we do not reject HO. Since the p-value is greater, since the p is high, we'll let it fly. We do not reject. The p-value tells us that this is an ordinary value. It is not unusual. Since it's not unusual, since it is ordinary, we do not reject HO. Here is a summary of our results. We had our weights and testing the claim that the mean is less than 16. We had our null and our alternate, the null hypothesis being that the mean is greater than or equal to 16, and the alternate hypothesis that the mean is less than 16. Our test results from the calculator, and our alpha being 0.05, and our p-value given at 0.1775. Since the p was high, we do not reject HO. The way to help you remember: if the p is low, the null must go. If p is high, let it fly. And then, to conclude this problem, we must write the sentence using, what's our significance level? 0.05. So using a 0.05 level of significance, there is not evidence to say that the mean weight is less than 16. And we have completed our example. We have another example, but we're running short on time, so I'll conclude part 1 here. Please watch part 2 for another example. Thank you.